Hello friends, my name is Ritesh and today we are going to solve yet another house robber problem which is a sequel to the previous house robber problem. So I would recommend if you haven't seen that video, please go back and check the house robber first problem video. In the previous problem, all the houses were present in a row and each house has an associated value. So a thief has to rob the houses such that he should not rob any two adjacent houses, and he has to maximize the loot amount. In this problem, the problem statement is same. The only difference is that the houses are arranged in a circle. So when the houses are arranged in a circle, what does that mean? It means that the first and the last house are connected to each other. Let's take an example. If you have an empty array, that means there is no house present, we have to return 0 as per the problem statement. If there is only one house, return the value of that house. If there are two houses, what does that mean? 3 is connected to 6, 6 is connected back to 3. Again, return the maximum of these two. Now take a look at the sixth line. So there are three houses, 3 is connected to 9, 9 is connected to 8, 8 is connected back to 3. So we cannot choose 3 and 8 at the same time because they are connected. It's a circle. So again, the maximum loot possible in this is 9. Another example, there are 4 houses, all of them are connected in a circle. So the maximum loot possible in this is 10 and 1. The last example, it has 1 is connected to 8, 8 is connected to 3, 3 is connected to 4, 4 to 9, 9 to 2, 2 to 5, and 5 back to 1. So the maximum loot possible in this is, we can choose 8, 9, and 5. Hence, 22 is the answer. So let's see how are we going to solve this. So the only difference between the previous house robber problem and this problem is that the first and the last element are connected to each other. That means we cannot choose the first and the last element together. So what if we break this problem into two problems such that, consider the case. So consider one is this array and second is this array. Hence, what I've done over here is, in the first array, I remove the last element and we will get the maximum loot amount from this. In the second array, I remove the first house and again we are going to calculate the maximum loot possible. So out of these two arrays, whatever will give me the maximum profit, that will be my answer. Okay, let's take a look at the code now. So the function loot over here is going to return the maximum loot amount possible for a given array or row houses where the first and the last house are not connected. So this is same as the house robber problem number 1. So you can go back and check that video, that how we calculated the maximum loot in a row house where first and last houses are not connected. Now see, this is the driver code, how we are calculating it. So here I'm just calling the function loot with starting with the 0 and eliminating the last element and starting with the first element including all rest of the elements. So whatever is the maximum out of this will be my result. Let's check the code. So for 2, 3, 2, 2 and 2 are connected, hence 3 is the answer. Let's take a look at the custom example. So this is the array that I have taken where the maximum loot possible is 8 plus 9 plus 5, hence 22. Let's see. There it is, as expected. So let's submit the code and see if all the test cases are passing. Yeah, accepted. It's a success. All right, that's it for today. Thanks for watching. Have a good day. Bye.